Hello, my name is Anne Carter and I'm a Project Officer for the Freshwater Habitats Trust. I'm going to talk to you today about our project, Testing the Water, which is part of the Brecks, Fen Edge and Rivers Landscape Partnership Scheme. First of all, a little bit of background about the Freshwater Habitats Trust. We started life as Pond Action back in the late 1980s, an organisation that subsequently became Pond Conservation, with Jeremy Biggs and Penny Williams at the helm. In 2013, we relaunched the charity as the Freshwater Habitats Trust to spearhead the fight against biodiversity loss in all of Britain's freshwaters, not just for ponds, but for all small water bodies, including streams, rivers and ditches. The Trust places particular emphasis on creating areas of clean water, something that has now almost vanished from large parts of the landscape and which is vital for our wildlife. So a bit about the Brecks, Fen Edge and Rivers Landscape Partnership. With funding from the Heritage Fund, this Landscape Partnership Scheme focuses on the Brecks Fenland Fringe, key freshwater habitats and primary river corridors that provide the conduit for biodiversity and early settlement of a hostile landscape. These areas are often overlooked in a landscape that is famous for being sandy and dry, yet they are the driving force behind the area's unique biodiversity and history of human settlement. We, the Freshwater Habitats Trust, rates the Brecks as one of Britain's top 3 landscapes for freshwater wildlife, being equivalent in importance to the New Forest in Hampshire and the Norfolk Broads. Its freshwater interests include biodiverse chalk streams, networks of ancient pingo ponds and fluctuating meres. The scheme focuses on the Brecks, Fen Edge and river landscape located on the borders of Norfolk, Suffolk and Cambridgeshire, and include the key Fen Edge area, river corridors and important freshwater areas that provide the conduits for biodiversity. On the western edge of the Brecks, the dry landscape changes dramatically into fenland, where ditch networks, despite being intensively farmed and increasingly disconnected, still have isolated freshwater hotspots supporting endangered species. The history of settlement and land use means that these assets, with their opportunities and stories, are on the doorstep of most of the population, yet despite or perhaps because of this, they often remain unacknowledged and overlooked. Over the 5-year delivery period between 2020 and 2024, working with partners and communities, the partnership aims to deliver a minimum of 24 projects. We are leading on one of these projects, Testing the Water, which is a citizen science project to raise awareness of habitat loss, pollution and rare species, involving people in practical activities to get new information about the project area through surveys, using cutting-edge environmental eDNA sampling of ponds, streams, ditches and river headwater streams, and rapid water quality test kits that make visible pollution that is otherwise invisible and largely unknown. This will help to achieve 4 broad aims. To map the extent of clean, unpolluted water, providing a baseline for long-term monitoring. To increase people's engagement with and understanding of the exceptional freshwater heritage of the Brecks. To inform the delivery of river restoration activities and guide future landscape conservation activities in the scheme area. Today, we'll be focusing on the use of our rapid water quality test kits. But first, I'd like to tell you a bit more about clean water testing and why it is so important. The first question is, what is clean water? Well, clean water is water without added pollution. Pollution includes nutrients such as phosphate and nitrate, but also a cocktail of other things in road runoff, sediment and pesticides. We define clean water as that which has a chemistry and biology which would be normal for a given area in the absence of human activity and disturbance. This is commonly referred to as a reference condition, minimally impaired water quality or natural background levels. Most freshwater plants and animals have evolved over millions of years in a world where the natural levels of nutrients in ponds, lakes, streams and rivers was very, very low. When more nutrients are added to the freshwater environment, this can cause profound changes and the freshwater wildlife struggle to adapt. Rare and sensitive species are lost first. If nutrient levels continue to rise, only very nutrient tolerant aggressive species will survive. Nutrients such as phosphate and nitrate act like fertiliser and increase the productivity of water bodies, including the growth of algae and plankton, which block light, use up oxygen, so larger organisms struggle to survive. For wildlife, clean water is key. If we want to see ecologically rich, self-sustaining freshwater habitats, then we need clean water habitats. So, just how bad is it? Well, research over the last 30 years has revealed that in lowland England and Wales there are no longer any undamaged rivers left. 87% of headwater streams are biologically degraded east of the line from the Humber to the Dorset coast, and 92% of ponds are biologically degraded. Plant richness has declined by 20% in the last decade. Also, there is just a single lake in England and Wales classified as undamaged, Burnmore Tarn in the Lake District. So why is water quality so poor? In the UK, a large part of the threat to fresh water is due to pollution, especially from intensive agriculture, runoff from urban areas and roads and sewerage. The single largest source of nitrate pollution comes from fertiliser, which is used to improve crop growth. The main source of phosphate pollution comes from detergents and sewerage. Most of England's rivers and lakes are highly polluted. Too many nutrients, heavy metals, pathogens, pesticides and sediment. And water bodies which drain large catchments, by their very nature, will pick up these pollutants. Extinction rates for freshwater species are 4 to 6 times higher than terrestrial and marine rates. The Water Framework Directive is a piece of European environmental legislation which aims to improve and protect the water environment on a catchment scale. The main aims of WFD are to prevent deterioration and enhance the status of aquatic ecosystems, to promote sustainable water use, reduce pollution, and to contribute to the mitigation of floods and droughts. Under the Water Framework Directive, running water habitats and some lakes are assessed using biological, chemical, and morphological metrics. In a one-out, all-out system, all elements have to achieve a minimum standard of good status. Below this minimum standard, ecosystems will become biologically degraded. As mentioned earlier in the presentation, high status is a reference condition, minimally impaired water quality, free from human disturbance and modification. The difference between good and high can mean a loss of 50% of species, so for us, good is not really good enough. As we can see on this map, there are very few good or high standard water bodies. If you look closely, you can see the blue lines, mainly in upland areas of Cumbria and Wales. The majority of monitored rivers, the orange and yellow on the map, fall into the moderate or poor category. It is also important to note that this data was only recorded from a small proportion of the freshwater environment. 99% of freshwater habitats, including ponds and small waters, fall outside of the statutory monitoring network. As part of the WFD, there is no data from the estimated 480,000 ponds. That is an awful lot of water to ignore. So what about the ponds? 2/3 of all freshwater plants and animals can be found somewhere in ponds. And ponds support around 100 priority species under the England BAP, which is now the S41/S42. The UK Biodiversity Action Plan was published in 1994 and was the UK government's response to the Convention on Biological Diversity, which the UK signed to in 1992 in Rio de Janeiro. The UK BAP describes the biological resources of the UK and provides detailed plans for conservation of these resources. This was superseded in 2006 in England by Section 41 of the 2006 Natural Environment and Rural Communities Act, the NERC. 1 in 5 ponds in semi-natural landscapes support at least one red data book species. Red lists are a globally recognised way of identifying the threat of extinction to species, including the internationally accepted Red List guidelines, developed by the International Union of Convention of Nature. So we know that ponds are threatened. In Great Britain, 1/3 of ponds existing 100 years ago have gone. The current estimate is around 480,000 ponds. There are, however, probably millions more seasonal ponds that have never been recorded and that have now disappeared. Better news is the data from the Countryside Survey, which took place in 2007, suggests the number of ponds is now increasing. However, the real problem is pond quality. Nationally, 80% of ponds are in poor or very poor condition, and only 10% in an undegraded state. Unlike pond numbers, the pond quality situation is getting worse. The number of very poor ponds increased by 20% between 1996 and 2007. So why are countryside ponds poor and declining? Well, the same reasons as for issues as running water. Intensive agriculture, particularly arable land, high in-stream flows, volumes, the presence of road runoff. But it's not all doom and gloom. Let's talk about some of the positives. A pioneering study was carried out by Penny and Jeremy, the founders of the Freshwater Habitats Trust, in the early 2000s to understand the difference between the conservation value of different freshwater habitats. Information about the relative biodiversity value of different water body types is a vital prerequisite for many strategic conservation goals. In practice, however, exceptionally few water body comparisons have been made. This study compared river, stream, ditch and pond biodiversity within an 80-kilometre area of lowland British countryside with intensive farming centred on the River Cole in Coles Hill, Oxfordshire. As you can see from this graph, at landscape scale, the ponds and the River Cole catchment were the richest habitats, a result echoed across Europe and perhaps beyond. In the River Cole catchment, the total number of plants found in all the ponds added together was around 65. In all the streams it was only 50. And this pattern, as we can see here, was repeated in every other catchment. The results showed that although all water body types contributed to the diversity of macrophytes and macroinvertebrates in the region, they differed in relative value. The findings as a whole suggest that ponds and other small water bodies can contribute significantly to global biodiversity. This contrasts markedly with their relative status in national monitoring and protection strategies, where small water bodies are largely ignored. So what makes ponds special? As we have seen, clean water. Although, as we have seen during the presentation, ponds are threatened by the same issues as running water, their small size and isolation means that they have avoided many of the pollution problems faced by other freshwaters. Many species traditionally associated with rivers find refuge in clean water ponds. Variety is another factor that makes ponds special. Ponds come in all shapes and sizes, whereas rivers are often relatively uniform across the whole catchment. The biotic communities will be influenced by the underlying geology, water source, surrounding habitat, proximity to other wetlands and the presence of intensive grazing. So overall, ponds collectively will be more diverse than the adjacent river in most wider countryside catchments. I'd now like to tell you a little bit about monitoring freshwater habitats and how getting involved with this project will help us to build up a picture of the clean water areas of the Brecks landscape. Firstly, a bit about the Clean Water for Wildlife survey that we carried out as part of our recent People, Ponds and Water project. For this project, we sent out thousands of clean water kits, the same kits we'll hopefully be using for this project, to volunteers across England and Wales. As you can see from the map, the bad news is that there was an awful lot of red dots indicating the extent of nutrient pollution. The good news, however, is that people still found clean, unpolluted water in all the landscapes they tested. The results also reveal for the first time the national importance of ponds in the clean water network. So now I'm going to show you a few other examples of clean water survey projects that we have delivered. The Ock is a river that drains into the River Thames in Oxfordshire. It mainly gets its water from areas of typical English countryside, which is used for heavy modern industrial farming. Dotted throughout the area are small villages and country towns. But even here, there are some small areas of woodland, meadow and marshes whose history can be traced back for thousands of years. These are often protected and managed as wildlife nature reserves. The clean water in the Ock Catchment is found in about 37% of water bodies. Almost all of these were ponds and lakes. Like most areas of lowland Britain, the majority of streams, ditches and all rivers suffer serious nutrient pollution. This is not surprising because the network of rivers drain water from a huge area of land with multiple sources of pollution from urban and agricultural sources. In contrast, some ponds can collect water from local clean sources, very small areas of land which aren't exposed to nutrient pollution. Of course, some ponds are polluted, particularly if they occur in intensively farmed fields or drain water from roads. Some of the tiny streams and ditches can also escape pollution for a time if they start their life in woodland or within nature reserves. No extra nutrients are being added to these places, so they're often havens for wildlife species that depend on clean water. The next example is the Lower Windrush Valley catchment. Almost 60% of the water bodies sampled in the Lower Windrush Valley showed no evidence of nutrient pollution. A high proportion of ponds and lakes were unpolluted. In contrast, the river sites all had high nutrient pollution, as were most of the stream sites. One well was sampled which also had high levels of nutrients. Our final example is the New Forest in Hampshire. The New Forest is one of the largest and most important areas for wildlife in England. It has lots of good habitats, including heathlands, woodlands, grasslands and lots of freshwater habitats, ponds, lakes, rivers, streams and ditches. In the New Forest you will see ponies, cows, donkeys and pigs grazing as they have done for hundreds of years. You won't see big farms, large towns or cities like in the rest of England. Clean water in the New Forest catchment is found in just over 3/4 of water bodies. Within the New Forest, the water is mostly clean and unpolluted, as the land has traditional low-density grazing, so few nutrients are being added to the landscape. Any nutrient pollution comes mainly from the towns and villages. The New Forest is one of the few places in southern England where lots of streams and rivers are still unpolluted. This is fantastic for wildlife, which has a huge choice of habitats to live in or move around. Not surprisingly, the New Forest is home to many of our most rare and threatened freshwater plants and animals. Outside of the New Forest, it is a very different story. Here, the land is farmed and the numbers of animals per field increase. This massively increases the amount of pollutants being added to the landscape, and as a result, many sites are highly polluted. Many freshwater plants and animals struggle to survive here, and the freshwater habitats are much poorer in wildlife. So how do these examples compare? As you can see, the New Forest comes out top for clean, unpolluted water, with the lower Windrush Valley a close second, with its many lakes and gravel pits, and the highly agricultural landscape of the Ock brings up the rear. So where is the clean water? As we can see, the majority of the clean water is made up of still water bodies, ponds and lakes, and interestingly, for the Ock and lower Windrush Valley, the gravel pit lakes. Following on from our survey, which I'm hoping you will be able to help with, we'll have a similar map of the Brecks area to compare with these examples. And finally, I'm now going to show you a few slides about our clean water test kits. Nutrient pollution is invisible, so often doesn't seem real to people. Quick kits make it possible for people to see pollution for the first time. And there's an opportunity to get data from sites which would not otherwise be monitored, and cheaply. Once a sample is taken, we can then compare the colour in the tube to the colour on the chart to find out how much pollution there is in the sampled water body. It is then possible to classify the site into 3 categories. No evidence of nitrate or phosphate pollution in the blue section, some nitrate or phosphate pollution, the green, and high or very high levels of pollution in the brown and burgundy. Thank you for listening.